Hello everyone, welcome to today's session. In this session, we will learn about the reinforcement learning. So let's move ahead and see what is reinforcement learning. Reinforcement learning is a part of machine learning where an agent is put in an environment and he learns to behave in this environment by performing certain actions. So it basically performs actions and it either gets a reward on the actions or it gets a punishment and observing the reward which it gets from those actions. Reinforcement learning is all about taking an appropriate action in order to maximize the reward in a particular situation. So, guys, in supervised learning, the training data comprises the input and the expected output, and so the model is trained with the expected output itself. But when it comes to reinforcement learning, there is no expected output. Here, the reinforcement agent decides what action to take in order to perform a given task. In the absence of a training dataset, it is born to learn from its experience itself. So, reinforcement learning is all about an agent who's put in an unknown environment and he's going to use a hit and trial method in order to figure out the environment and then come up with an outcome. Now let's look at reinforcement learning within an analog. So consider a scenario where a baby is learning how to walk. The scenario can go about in two ways. Now in the first case, the baby starts walking and makes it to the candy. Here, the candy is basically the reward it's going to get. So since the candy is the end goal, the baby is happy. It's positive. So the baby is happy and it gets rewarded with a set of candies. Another way is which this could go is that a baby starts walking but falls due to some hurdle in between the baby getting hurt and it doesn't get any candy and obviously the baby is sad. So this is a negative reward or you can say this is a setback. So just like how we humans learn from our mistakes by trial and error, reinforcement learning is also similar. So we have an agent which is basically the baby and a reward which is the candy over here. And with many hurdles in between, the agent is supposed to find the best possible path to read through the reward. So guys, I hope you all are clear with the reinforcement learning. Now let's look at the reinforcement learning process. So generally, a reinforcement learning system has two main components. The first is an agent and the second one is an environment. Now in the previous case, we saw that the agent was a baby and the environment was a living room where the baby was crabbing. The environment is the setting that the agent is acting on and the agent over here represent the reinforcement learning algorithm. So guys, the reinforcement learning process starts when the environment sends a state to the agent and then the agent will take some actions based on the observations. In turn, the environment will send the next state and the respective reward back to the agent. The agent will update its knowledge with the reward returned by the IMENT and it uses that to evaluate its previous action. So guys, this loop keeps continuing until the environment sends a terminal state, which means that the agent has accomplished all his tasks and he finally gets the reward. This is exactly was depicted in this scenario. So the agent keeps climbing up ladder until he reaches his reward. To understand this better, let's suppose that our agent is learning to play Counter Strike. So let's break it down now. Initially, the RL agent, which is only the player 1. Let's say it's player 1 who is trying to learn how to play the game. He collects some state from the environment this could be the first state of counter strike. Now, based on the state, the agent will take some action, and this action can be anything that causes a result. So, if the player moves left or right, it's also considered as an action. So, initially, the action is going to be random because obviously, the first time you pick up counter strike, you're not going to be a master at it. So, you're going to try with different actions and you're just going to pick up a random action in the beginning. Now, the environment is going to give a new state. So, after clearing that the environment is now going to give a new state to the agent or to the player. So, maybe he's across stage 1. Now, he's in stage 2. So, now the player will get a reward from the environment because it cleared stage 1. So, this reward can be anything. It can be additional points or coins or anything like that. So, basically, this loop keeps going on until the player is dead or reaches the destination, and it continuously outputs a sequence of state actions and rewards. So, guys, this was a small example to show you how the reinforcement learning process works. So, you start with an initial state, and once a player clears that state, he gets a reward. After that, the environment will give another stage to the player, and after it clears that stage, it's going to get another reward, and it's going to keep happening until the player reaches his destination. So, guys, I hope this is clear. Now, let's move on and look at the reinforcement learning definition. So, there are a few concepts that you should be aware of while studying reinforcement learning. Let's look at those definitions over here. So, first, we have the agent. Now, an agent is basically the reinforcement learning algorithm that learns from trial and error. So, an agent takes actions like, for example, a soldier in Counter Strike navigating through the game. That's also an action. If he moves left, right, or if he shoots at somebody, that's also an action. So, the agent is responsible for taking actions in the environment. Now, the environment is the whole Counter Strike game. It's basically the world through which the agent moves. The environment takes the agent's current state and action as input, and it returns the agency reward and its next state as output. Next, we have action. Now, all the possible steps that an agent can take are called actions. So, like I said, it can be moving left, right, or shooting or any of that. Then we have a state. Now, state is generally the current condition returned by the environment. So, which state you are in? If you are in state 1 or if you are in state 2, that represent your current condition. Next, we have a reward. It is generally an instant return from the environment to appraise your last action. So, it can be anything like coins or it can be additional points. So, generally, a reward is given to an agent after it clears the specific stages. Next, we have a policy. Policy is basically the strategy that the agent uses to find out his next action based on his current state. Policy is just a strategy with which you approach the game. Then we have value. Now, value is the expected long-term return with discount. So, value and action value can be a little bit confusing for you right now. But as we move further, you will understand what I'm talking about. So, value is the long-term return that you get with a discount. Discount, I'll explain in the further slides. Then we have the action value. Now, the action value is also known as Q value. It's very similar to what you except that it takes an extra parameter, which is the current action. So here you will find out the Q value depending on the particular action that you took. So guys, don't get confused with value and action value. We'll look at examples in the further slides and you will understand this better. So guys, make sure that you're familiar with these terms because you will be seeing a lot of these terms in the further slides. Now, before we move any further, I'd like to discuss a few more concepts. So first, we will discuss the reward maximization. So if you haven't already realized that the basic aim of the RL agent is to maximize the reward. Now, how does that happen? Let's try to understand this in depth. So the agent must be trained in such a way that he takes the best action so that the reward is maximum, because the end goal of reinforcement learning is to maximize your reward based on a set of actions. So let me explain this with a small game. Now in the figure you can see there is a fox, there's some meat, and there's a tiger. So our agent is basically the fox and his end goal is to eat the maximum amount of meal before being eaten by the tiger. Now since the fox is a clever fellow, he eats the meal that is closer to him rather than the meat which is closer to the tiger. Now this is because the closer he is to the tiger, the highest are his chances of getting killed. So because of this, the reward which are near the tiger, even if they are bigger meat chunks, will be discounted. So this is exactly what discounting means. So our agent is not going to eat the meat chunks which are closer to the tiger because of the risk. Now, even though the meat chunks might be larger, he does not want to take the chances of getting killed. This is calling discounting. This is where you discount because it is improvised and you just eat the meal which are closer to you instead of taking risk and eating the meat which are closer to your opponent. Now, the discounting of reward works based on a value called gamma is between 0 and 1. So the smaller the gamma, the larger the discount value. So if the gamma value is lesser, it means that the agent is not going to explore and he is not going to try and eat the meat chunks which are closer to the tiger. But if the gamma value is closer to 1, it means that our agent is actually going to explore and it's going to try and eat the meat chunks which are closer to the tiger. I'll be explaining this in depth in the further slides. So don't worry if you haven't got a clear concept yet. But just understand the reward maximization is a very important step when it comes to reinforcement learning because the agent has to collect maximum reward by the end of the game. Now let's look at another concept which is called exploration and exploitation. So exploration, like the name suggests, is about exploring and capturing more information about an environment. On the other hand, exploitation is about using the already known exploited information to hide in the rewards. So guys, consider the fox and tiger example that we discussed. Now here, the fox eats only the meat chunks which are closer to him, but he does not eat the meat chunk which are closer to the tiger. Even though they might give him more reward, he does not eat them. If the fox only focuses on the closest rewards, he will never reach the big chunks of meat. This is what exploitation is about. You are just going to use the currently known information and you are going to try and get rewards based on that information. But if the fox decides to explore a bit, it can find the bigger reward, which is the big chunks of meat. This is exactly what exploration is. So the agent is not going to stick into one corner. Instead, he is going to explore the entire environment and try and collect bigger rewards. So, guys, I hope you all are clear with exploration and exploitation. Now, let's look at the Markov decision process. So, guys, this is basically a mathematical approach for mapping a solution in reinforcement learning. In a way, the purpose of reinforcement learning is to solve a Markov decision process. So, there are a few parameters that are used to get to the solution. So, the parameters include the set of actions, the set of states, the rewards, the policy that you are taking to approach the problem, and the value that you get. So, to sum it up, the agent must take an action, a transition from a state, or I can say a start state to the end state S. While doing so, the agent will receive a reward R for each action that he takes. So, guys, a series of actions taken by the agent define the policy or define the approach, and the rewards that are collected define the value. So, the main goal here is to maximize the reward by choosing the optimum policy. Now, let's try to understand this with the help of the shortest path problem. I'm sure a lot of you might have gone through this problem when you were in college. So, guys, look at the graph over here. So, our aim here is to find the shortest path between A and B with minimum possible cost. So, the value that you see on each of these edges because basically denotes the cost. So, if I want to go from A to C, it's gonna cost me 15 points. So, let's look at how this is done. Now, before we move and look at the problem, in this problem, the set of states are denoted by the nodes, which is ABCD, and the action is to traverse from one node to the other. So, I'm going from A to B. That's an action. Similarly, A to C, that's an action. The reward is the cost, which is represented by each edge over here. Now the policy is basically the path that I choose to reach the destination. So let's say I choose A, C, D. That's one policy. In order to get to D and choosing A, C, D, which is a policy, it's how I'm approaching the problem. So guys, here you can start off at node A and you can take baby step to your destination. Now initially you are clueless, so you can just take the next possible node which is visible to you. So guys, if you are smart enough, you are going to choose A to C instead of ABCD or ABD. So now if you are at node C, you want to traverse to node D. You must again choose a wise path. So just have to calculate which path has the highest cost or which path will give you the maximum rewards. So guys, this is a simple problem. We are just trying to calculate the shortest path between A and D by traversing through these nodes. So if I traverse from ACD, it gives me the maximum reward. It gives me 65, which is more than any other policy would give me. So if I go from ABD, it would be 40. When you compare this to ACD, it gives me more reward. So obviously, I'm going to go with ACD. So it was a simple problem in order to understand how a Markov decision process works. I want to ask you a question. What do you think? I did here. Did I perform exploration or did I perform exploitation? Now the policy for the above example is exploitation because we didn't explore the other nodes. We just selected 3 nodes and we traversed through them. So that's why this is called exploitation. We must always explore the different nodes so that we find a more optimal policy. But in this case, obviously, ACD has the highest reward and we are going with ACD. But generally, it's not so simple. There are a lot of nodes, there are hundreds of nodes you traverse, and there are like 50, 60 different policies. So you make sure you explore through all the policies and then decide on an optimum policy which will give you a maximum reward. So, this is all about the reinforcement learning. If you have any doubt or any query, you can ask in the comment section. Thank you so much for watching the video.